Okay, welcome back, and the next video we're going to be starting our C2 course. So the first topic that we're going to learn here is about our algebraic long division. Now, I'm well aware that a number of you will not have done long division for quite a while, particularly if you were in the IGCSE class. So don't panic. What you can do, you can always look up how your long division works, obviously, but also we're going to go through this just algebraically to start with, and hopefully you'll kind of see how it works. So the first thing I'm going to do is we're going to divide. So let's just write this, the question, what it is. We're going to divide. Should have used my typing here. The following thing, which is a polynomial, and it's going to be 6x cubed plus 28x squared minus 7x plus 15 by x plus 5. So I need to set this up. Now, previously, if you've been doing any sort of division, you might have been able to see if you could factorise something on the top and factorise it on the bottom and see if things will cancel out. It's not going to be possible here. Factorising, it might be possible. Factorising our cubic term, it's going to become really tricky. It's not a technique that we really are able to do. So we're going to have to use long division to do it. As I said, it's exactly the same technique as you find previously on your long division. So, how do we set it up? We take our x plus 5 because that's what we're dividing by. Let's go red. So we're going to take our x plus 5, and I'm going to use this bus stop idea that you'll have seen throughout school and divide it by 6x cubed plus 28. I don't mean divided by, I mean this is what we're dividing by. Squared minus 7x plus 15. Okay, let's just extend this on over. Okay. So that's what we're doing. X plus 5 is the divider, and we're starting with our 6x cubed plus 28x minus 7x plus 15. Okay, so the first thing we're going to work in terms of individual terms. So if I was to have my 6x cubed and I'm dividing it by x, what would I be left with? So we're just going to deal with, first of all, this dividing by the x, and that makes life a lot easier, and the rest kind of hopefully will fall into place. So what would that be? Well, above it would be 6x squared. Don't know if I've given myself enough room. Hang on, let's just go back. Let's create a bit more room. Okay, I think I've got it. That should give me a bit more room. Okay, so the first thing I did, just to recap, I've taken this 6x cubed and I'm dividing it by x, and so I'm writing the result of that above, which gives me 6x squared. Okay, now what I need to do is I need to take my 6x squared and I need to go through the process of multiplying it by this to just check that what we've done is the correct division. So, take your 6x squared, whatever you've got up here, multiply it by x. That gives me, obviously, 6x cubed. Oops, I need to write with something. That gives me, in blue, my 6x cubed. Okay, but it also needs to multiply with this plus 5. The plus 5 is having an effect, so we need to see what kind of effect it's having with this 6x squared. So 6x squared times 5, I need to multiply through, and I'm just going to line it up with the correct coefficient. So 6x squared times 5, I know it's going to give me 30x squared. So I know it's an x squared, so it's going to go below this. So it was positive, so 30x squared. Okay. Okay, so now I'm going to perform a subtraction, really, just to see what I'm left with, how many x squareds, how many x cubes I'm left with. Hopefully I'm not left with any x cubed if my original division was correct. So if I was to draw a line under this, the 6x cubed minus 6x cubed, that becomes 0, so I don't need to write anything below. What I'm going to do is this similar subtraction here to see how many x squareds I'm left with. So 28x squared minus 30x squared, that's going to make let's go for another colour this time, minus 2x squared. Now, the other bit that's going to be affected by this is the x term. So all I do is I bring it down. So take this minus 7x, bring it down. And so I've got minus 2x squared minus 7x. Now, this is what I'm working with now, and I'm going to go through exactly the same procedure as before. So, I take my minus 2x squared and I divide it by that x. It's always going to be that x that I'm going to do first, and then I'm going to see how it works with the 5 and make it work afterwards. So, minus 2x squared divided by x should give me minus 2x. So, above here, I'm going to go minus 2x. Okay. Again, same process again. Let's see what happens when I multiply this second term I've got by the x and then by the 5. Well, first of all, minus 2x times x gives me that minus 2x squared, which is why I did it. So when I do my subtraction in a second, it's going to work. Now, what is, the next question, this is what I have to think, minus 2x times 5 should give me minus 10x. Okay, and now we're going to start a new subtraction. I've done my two terms, the things that are affected by the x and the 5, and so let's jump back in. And so I'm going to, oops, didn't mean to move that over there. Let's try and draw. There we go. Now let's do a subtraction again. So, first of all, what is minus 2x squared take away minus 2x squared? That would be minus 2x squared plus 2x squared, so that becomes 0, which is what I want. And then minus 7x take away minus 10x should give me 3x. Similar to before, I'm going to bring the next term down, which is that 15. Plus 15. Now, if this works without any remainder, we'll see in a second how that happens. Again, I've got two terms here. So, first of all, I'm going to look at this one, and I'm going to think about what I need to do. I need to divide it by this thing. So 3x divided by x is just an x. So I'm going to almost run out of space. Let's give me a little bit more. So what did I just say? I said 3x divided by x is 3. So that should just be a plus 3 on the end there. Now, let's see what happens when I see what effect that has on with the numbers. And you might be able to spot this already. So, this 3 times by x gives me the 3x that I want down here. And then finally, the 3 divided by, 3 times 5 gives me that 15. So, let's see what remainder I've got left over. When I do my subtraction, which I do need a touch more room for, I do my subtraction at the end. 3x minus 3x is 0, 15 minus 15 is 0, which means there's no remainder at the end of my division. So what I've done is I've done this thing here divided by this to give me this. We're going to write that out as a bit of a summary then. Let's just do that. In fact, let's go to the side because I can't know what. So we can say six x cubed plus 28x squared minus 7x plus 15 divided by x plus 5. Well, that is equal to the answer that I got, which was 6x squared minus 2x plus 3. Now, you might have to use that in a number of different ways as the questions develop. Initially, all I'm going to ask you to do is to have a go at some of these, and you're going to do these divisions and get your answer really at the end. But it's just worth noting that you might then use, obviously, 6x cubed plus 28x squared minus 7x plus 15 is equal to x plus 5, 6x squared minus 2x plus 3. Which in itself might be something that you're going to use if we think about fully factorising our original cubic. Now we've got a linear and a quadratic, and you might be able to factorise it further. Probably could, but that's not what we're going to do in this case. So that really is the process that you need to go through. Okay, so in that first example, everything was quite nice and neat. We found it fit into exactly, and we didn't have any remainder. You might get a situation where you're asked about a question that does contain a remainder. So I'm going to go through that process, which will give you a chance to see the process of the long division once more, and also what you do when you get some sort of remainder. So, question 2 is going to be x cubed plus x squared minus 36, and that's going to be divided by x minus 3. So all of this is being divided by this. Okay, first thing you might notice, I hope you notice, we've got a cube, we've got a squared. We don't have an x term, but we do have a number. Now, the process for doing this is we need to include that x term. It's going to happen. It's going to have some sort of impact on our final result. So we need to remember to put it in. So when we draw our division out, we can do x cubed plus x squared. Now for the x, I'll just put 0x minus 36, because we are going to have to consider that that's going to be part of this. Okay, so process once more. Starting point here, and I'm going to divide by the x. So that's quite nice and straightforward. I get an x squared. So my x squared, I need to just check that how it works, so I multiply through by what I divided by. So x squared times x gives me x cubed. And then also, because the minus 3 has an effect, x squared times minus 3 makes minus 3x. So plus minus 3x squared. Okay, let's do the subtraction. We can see that these two cancel out, and then I've got an x squared minus, because I'm always going to take away, minus 3x. So that's going to be 4x squareds. Again, I'll bring this down just to go and sit next to it, because that's what I'm going to be dealing with in my next term that I find. So 4x squared plus 0x. Oh, plus 0x, that's an interesting thought. Let's not dwell on that for now. Okay. So, next thing I jump to straight away is what I'm dealing with, what's being divided by this x, and I think about 4x squared divided by x, that gives me 4x. Okay. Once I've got my 4x, I work the other way. 4x times by x gives me the 4x squared I want. And 4x times by minus 3 gives me minus 12x. Okay, 2 terms done. The effect of the x and the minus 3 has been considered, so now I'm going to go down and perform my subtraction once again. So, 4x squared minus 4x squared, that gives me nothing. Perfect, that's what I want. And then 0, take away minus 12x, that should be 12x. Okay, bring the next term down. And it's 12x minus 36. That is 36, isn't it, up there? So 12x minus 36. Okay. Perform the division with my x. So I've got 12x divided by x, which I know is going to have to be 12. So let's go back up. And I know that, as I said, is going to be 12. So, what do I got? 12 times x. Now I'm going to do my subtraction. 12 times x is 12x. And then 12 times minus 3 is minus 36. And I was hoping for a remainder. This one worked perfectly. How did that happen? Okay, anyway, let's just finish it off then. So what have I got? I'm doing my final subtraction, just seeing if I've got a remainder. 12x take away 12x. This 12x take away 12x is nothing. And minus 36 take away minus 36 is also nothing. So I could put in that there's a nothing there if I like, just to show that there's no remainder. Now, the key thing is, I suppose on this example though, you need to remember when you don't have a term, whether it's cubed, squared, or wherever it is missing, you put that 0 in there so that it can be used, because you do need to bring that down. It does need to be considered, and that minus 12 taken away from it. So that's important here, so this process was worth doing a second time. Now, I'm going to give you a for instance, which doesn't work in this example, and you can just add this to your notes. And let's go kind of red. We can say, if there was a number left here this would be the remainder. So you will see over the coming lesson or two that you'll get asked a question. What is the remainder when some polynomial is divided by a linear term? If you're asked to find the remainder, you need to go through the whole process and then just quote this number as being your remainder. And that really is essentially it. Obviously it worked perfectly this time. We've got it so there's no remainder, which is quite nice. So we can see once again, in a sense, that division can be done. But there's two examples of our algebraic long division, and it's quite long-winded, I suppose, but it can be quite therapeutic. So if you relax, just go through the process, make sure you write it out each time. The answer just kind of falls out, and just follow that algorithm, if you like, that process of how to do it, and you'll get there without any trouble at all. And that is the end of our video, the first on C2, which is all about algebraic long division.